Here's a design example that's in your book. It's example 14.4 and sort of shows the trial and error design process that we've talked about up to this point. Basically, we're supposed to, using ASD, pick out a W12 section that has to hold a required bending moment of 250 foot-kips. And we talk about the beam being 12 feet long and being unbraced, so the unbraced length is 12 feet. So again, the first two steps that we've talked about earlier in the process basically say something like this. Let's assume that this is going to be controlled by category 1 behavior. That is, let's assume that the plastic moment behavior controls this beam. And the second thing is, then with that assumption, let's calculate an RY minimum value that it would take for a section to be in category 1. So steps 1 and 2, basically you can do either one of them first, but in this example we show the unbraced length of 12 feet being set equal to the LP formula, and then solving for RY minimum. The RY minimum value that we calculate using an E of 29,000 and an FY of 36,000 or 36 KSI is 2.88. So any section that we choose with an RY for that section that's above 2.88 is automatically in category 1. That's what this says. And the second thing we show up there on the screen is we say, well, let's assume that we are in category 1 and let's solve for the ZX required that we'll need to carry this moment, this required moment. So we set 250 foot-kips equal to the design capacity. We're using ASD, so the design capacity is ZX times FY divided by your safety factor. So let's solve for ZX. And then, as you can see, the ZX that we'll need to carry 250 foot-kips is 139.2 inches cubed. So what we'll say is, well, looking through our tables, we need a ZX that's greater than 139.2, and we choose a W12 by 96. That has a ZX of 147, so that's greater, so of course that would work. But then the question is, are we in category 1? We've assumed that we are we or not? So the step 3 is a check. Let's look at this 12 by 96. We know it has the proper plastic section modulus. It has an RY value of 3.09 inches. That RY value is above the RY minimum value, and that confirms that we are in fact a category 1 type of beam. So our behavior is correct. Now conversely, what you could do, if you don't like doing this, you could simply calculate what the LP value is, use the LP formula and calculate the LP value for a 12 by 96. What you'll find out is the LP value is greater than 12 feet your unbraced length, so you'd say, yeah, hey, I am in category 1. Since we've confirmed that we are in category 1, we just finished the problem off. We calculate the design capacity for this 12 by 96. The design capacity comes up to be 264.1 foot-kips. We compare that to 250 foot-kips, what we had to hold, and of course, since we're greater, this W12 by 96 works.